we have finished overview of vector algebra, dot product, cross product and coordinate system. So there are the three types of the coordinate system: Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. And we have also studied about the relationship between Cartesian and cylindrical, Cartesian and spherical coordinate system. So now in today's lecture we discuss about how to convert a point and vector from one coordinate to the another coordinate system. And in next lecture we will discuss about what is del operator, divergence, gradient and column. Okay, so in today's lecture we discuss how to convert a point and vector from one coordinate to the another coordinate system. Okay, so as we know that there are the three types of the coordinate system. First coordinate is Cartesian coordinate system. The Cartesian coordinate system is represented using x, y, z. Next coordinate system is cylindrical coordinate system, which is represented using rho, phi, z. And last, the third coordinate system is spherical coordinate system, which is r, theta and phi. Okay, now we have to derive a relationship between Cartesian to cylindrical and Cartesian to spherical coordinate system. Okay, so I have to just write the equation. So first I have to relate x, y, z with rho, phi, z. Okay, so I have to just write first relationship between these two coordinate systems that we have already discussed in our last lecture. So what is x? X is equals to rho cos phi, y is equals to rho sin phi, and z is equals to z. Next, next is cylindrical coordinate system in terms of rectangular coordinate system. Rho is equals to under root of x square plus y square. Phi is equals to tan inverse y by x, and z is equals to z. Okay. Next, we write relationship between x, y, z with r, theta and phi. So x is equals to r cos phi sin theta, y is equals to r sin phi sin theta, z is equals to r cos theta. Okay, and r is equals to under root of x square plus y square plus z square. Theta is equals to cos inverse z by r, or you can write z divided by under root of x square plus y square plus z square. And phi is same. Phi is equals to tan inverse y by x. Okay, so these are the relationship between these two coordinate system. Okay, we have also write the relationship between unit vector when we do the dot product. Okay, so here in this case, for Cartesian and cylindrical coordinate system, I have to just first of all write their unit vectors. Okay, so ax, ay, az relationship with a rho, a phi and az. So how can you write this relation? So first x and rho, so x and rho, so this cos phi, so I have to just write cos phi. Then y and rho, so y and rho, so this sin phi, so sin phi. Z and rho, okay, so z and rho both are in the same coordinate system. So if I have to do the simple dot product, okay, these are the relation for the dot product. I have to just do the dot product, so answer is 0. Now what I have to do, I have to just do the differentiation of first column. So cos phi differentiation minus sin phi differentiation cos phi, 0 differentiation 0. Now ax dot az both are in the same coordinate. Okay, so answer is 0. ay dot az, answer is 0, and az dot az sorry, answer is 1. Okay, similarly we can write the dot product relationship between Cartesian coordinate and spherical coordinate system. Okay, so this topic is left. Okay, this topic we don't actually we did not discuss in our last lecture. Okay, so here it is ax, ay, az, and here ar, a theta, a phi. Okay, now what I have to do? First x and r, so here it is x and r, so cos phi sin theta. Okay, then ay and ar, so y and r, so it is sin phi sin theta. This one is very easy, you have to just remember these things. Okay, then z and r, so z and r, so it is cos theta. So here it is cos theta. Okay, now what I have to do? I have to do the differentiation of my first column with respect to theta, and I have to consider phi is a constant term. Okay, so cos phi is constant, I will just do the differentiation with theta, so it is cos theta. Again phi is a constant term, I have to just do differentiation with theta, so it is cos theta. I have to do the differentiation with theta, so it is minus sin theta. And last term is ax with a5, ay with a5, az with a5. So ax with a5, so you can see here ax with a5, answer is minus sin 5, so it is minus sin 5. Ay with a5, answer is cos 5. Okay, and az with a5, answer is 0. Okay, so to convert a point and to convert a vector from one coordinate to the another coordinate system, you have to just remember these whole things. Okay, so these equations, okay, these equations are useful to convert a point from one coordinate to the another coordinate system, and this matrix is used to convert a vector from one coordinate to the another coordinate system. Okay, so what I will do, I will just pick up a small example. Okay, and we'll give how to convert a vector from one coordinate system to the another coordinate system, and how to convert a point also from one coordinate to the another coordinate system. Okay, so this one is my reference. Okay, so this all the equations and these two matrix, these two tables, okay, we will keep as our reference. You have to just remember this. Okay, and it's very easy. Okay, so now I have to pick up a example. You can take any example. Okay, so we can solve it. So example is convert a vector or convert a point. Okay, convert point P. The value of point P is 2, -3, 4. Convert this point P into into the cylindrical and spherical coordinate system. Okay, so first of all we have to identify the point is given in which coordinate. Okay, so no angle is present. Okay, listen, how to identify whether the point is present in Cartesian coordinate, cylindrical or spherical coordinate system. Okay, so here if only one angle is present, so we can say that the point in the cylindrical coordinate system, and if two angles are present, so we can say the given point in the spherical coordinate system. Okay, so no angle is present, so we can say that the point is present in our Cartesian coordinate system. Okay, so value of x is 2, value of y is minus 3, and value of z is 4. Now first I have to convert, okay, first I have to convert the point into the cylindrical coordinate system. Okay, so convert this point into cylindrical coordinate system first. So I have to use which equation? I have to use this equation. Value of x, y and z is given, so you have to just convert this point into this cylindrical coordinate system. Okay, so I have to find the value of rho, phi and z. Okay, so what is rho? Rho is under root of x square plus y square. Okay, so rho is equals to under root of x square plus y square. Okay, so it is under root of x square 4, y square 9. So answer is under root of 13. Okay, now next is 5. So phi is equals to tan inverse y by x. Okay, now here it is tan inverse, value of y is minus 3 and value of x is 2. Okay, now see here, this one is important, okay, because most of the students do mistake here. How? So I will explain you how to identify this angle actually. Okay, how to actually see here, if the value of y is 3, okay, and value of x is minus 2, you will get the same answer. Okay, see here, I have to just do this. Phi is equals to tan inverse minus 3 by 2. Okay, so tan inverse minus 3 by 2 minus 3 by 2. Okay, so answer is minus 56.30. Note down this answer. Answer is minus 56.30. Now I have to do tan inverse 3 by minus 2. Okay, tan inverse 3 divided by minus 2. Okay, the answer is same, minus 56.3. Okay, but answer should not be same because value of x and value of y are different in both the cases. So what we have to do, so if you know, we have the idea about this 4 quadrant. Okay, this one is my positive x-axis, this is my negative x-axis, positive y-axis and negative y-axis. Okay, so suppose the point is present here. Okay, so point is present here, so this point has a positive x value and a positive y value. Suppose point is present here. Okay, suppose point is present in the first quadrant. Now the point is present in the second quadrant. So in the second quadrant, the value of x is negative, value of y is negative. Suppose point is present in the third quadrant. So in the third quadrant, both the value are negative, and point is present in last fourth quadrant. So value of x is positive and value of y is negative. Okay, so in all the case, the value of angle are differ. The value of angle are different in all the cases. How? So if point is present here, the value of phi, that means if both x and y are positive, so phi is equals to tan inverse y by x. If point is present in the second quadrant, so value of phi is equals to 180 degree minus tan inverse y by x. Suppose my point is present in the third quadrant, so value of phi is equals to 180 degree plus tan inverse y by x, and point is present in the fourth quadrant, so value of angle phi is equals to minus tan inverse y by x. Clear? Okay, so our given point is present in which quadrant? Y is negative and x is positive. Okay, so here y is negative and x is positive. Okay, so we use this equation for this case. Okay, so for our example we have to use this equation. Okay, so now see here, I have to just put minus sign here. Now no need to put negative sign, because this negativity, minus 3 negativity is already reflected here. Okay, so it is tan inverse 3 by 2. Okay, so tan inverse 3 by 2, answer is 56.30. So my answer is minus 56.30 degree. So value of phi is 56.30. Okay, suppose for example x is minus 2 and y is plus 3, then point is present in which quadrant? X is minus 2 and y is plus 3. So this point is present in the second quadrant. So I have to use phi is equals to 180 degree minus tan inverse y by x. Now in this case I have to put y is equals to 3 and x is 2, not minus 2, because this negativity is already I have to reflect it here, 180 degree minus tan inverse. Okay, so this 180 degree minus tan inverse 3 by 2, not 3 by minus 2. Okay, I have to just write 180 degree minus tan inverse 3 by 2 if x is minus 2 and y is plus 3. Clear? Okay, so I have to find out the value of rho 5 and what is z? Z is same, which is 4. Okay, so I have to convert my point in a first cylindrical coordinate system. Okay, similarly you can convert this point in spherical coordinate system also. Okay, so I have to use this relationship to convert a point into the spherical coordinate system. Okay, so value of r is this one, value of theta and value of phi. Okay, so here r is equals to, okay, so second is to convert a point into spherical coordinate system. Okay, so r is equals to under root of x square plus y square plus z square. Okay, so this under root of 4 plus 9 plus 16. Okay, so 4 plus 9 plus 16, so this under root of 29. Okay, 4 plus 9 plus 16. Okay, 4 plus 9 plus, yes, it is under root of 29. So this value of r. Theta is equals to cos inverse z by r. Okay, so this cos inverse z, value of z is 4 and value of r is under root of 29. Okay, see here we have to apply this case only for y by x, tan inverse y by x, not for cos. Okay, so it is 4 divided by root 29 cos inverse, so it is 42.03 degree. Okay, and last 5, what is 5? 5 is same, which is tan inverse y by x. Tan inverse y by x, we will get the same answer, which is minus 56.30. So our answer is minus 56.30. Okay, so I have to convert my point into the cylindrical coordinate system and in spherical coordinate system. Okay, so in cylindrical coordinate system, I can write the point in this way. In a cylindrical coordinate system, p of under root 13 comma minus 56.3 degree comma 4. Okay, and in spherical coordinate system I can write the point in this way, p of under root of 29 comma 42.03 degree comma minus 56.30. Okay, so in this way you can convert your point from cylindrical, means from one coordinate to the another coordinate system. Okay, so here I have to just pick up the one example. Suppose the point is already given in cylindrical coordinate system. So how can you convert in the Cartesian coordinate system? We have to use this one. Okay, now the most important thing is, suppose the point is given into the cylindrical coordinate system and you have to convert into the spherical coordinate system. So what you have to do? First of all, we have to convert this point into the Cartesian and then after from the Cartesian to the spherical coordinate system. Okay, so it's very easy to convert a point from one coordinate to the another coordinate system. Okay, so I will just take here one simple example. You can solve so many multiple examples also. Okay, so here, so this one is just a point conversion from one coordinate to the another coordinate system. Now I have to pick up example for vector. How to convert a vector from one coordinate to the another coordinate system. Okay, so suppose it is a one example. An example say that convert a given vector, convert a vector A. You can take any vector. Okay, I have to take vector A, tan ax plus 4ay plus 2az. Convert a vector tan ax plus 4ay plus 2az into cylindrical coordinate system. Into cylindrical coordinate system. Okay. Then we will discuss about how to convert into the spherical coordinate. But first we understand how to convert the given vector into the cylindrical coordinate system. At a point, now the point is also given. At a point P of x, y, z. See here, the point is x, y, z. No value is given. It's a generalized x, y, and z. So now how to convert a vector into cylindrical coordinate system at this point. Okay, so in some example the value of point is also given, but here the value of point is not given. It is given that the point value is x, y, z. Okay, we will discuss about if the point value is given, then how to convert it. Okay, the method remains same. Okay, so now solution. The vector is given in which coordinate? This vector is given into the x, y, z, means in Cartesian coordinate system. So here vector A is equals to capital AX plus capital AY plus capital AZ into small, sorry, it's a small, okay, capital AZ into AZ. Okay, so AX, AY, and AZ. What is the value of AX? Value of AX is 10. Value of AY is 4. Okay, it is given already. And value of capital AZ is 2. Okay, these are given in example. Now we have to convert this vector A into the cylindrical coordinate system. And which are the variable for the cylindrical coordinate system? Rho, phi, z. Okay, so we have to just assume this vector A has a rho into rho plus a5 into a5 plus az into az. So now what you have to do? You have to just find out these three values. Which are the three values? You have to find out the value of a rho, value of a5, and value of az from the value of ax, ay, and az. Okay, so once if you find the value of capital A rho, capital A5, and capital AZ, we have to put this value into this equation. So now we will get our answer. Okay, so finally we have to convert my vector into this cylindrical coordinate system. Clear? Okay, if you notice one thing, z and z, these two are same, az and az. So value of this az is 2, because here capital Az is 2, so this Az is 2. But still we have to calculate the value of Az, and we will prove this both Az are same. Okay, so first I have to find Az. Okay, so first of all find a rho. Okay, first I have to find a rho. What are the calculation I have to do for a rho? We will do the same calculation for a5 and az also. Clear? Okay, so I have to find the value of a rho. So how to find out a rho? So a rho is equals to capital A rho is equals to a vector dot a row unit vector. Okay, how this a rho is equals to a vector dot a rho, how this equation comes? See, this one is an important equation. Okay, how it comes? How it comes? So see here, this one is our assumed vector. Okay, if I have to do left hand side and right hand side with dot product with arrow, okay, you have to just do the dot product with arrow at the right hand side and the left hand side. Okay, see here, I have to explain you, so we will get the clear cut idea about what I have to do here. Okay, I have to just do the dot product with arrow at the right hand side and the left hand side. Okay, so this one, a vector dot arrow is equals to this whole vector is dot product with arrow. Okay, so arrow plus a5 plus az is dot product with arrow. Okay, so as we know that arrow dot arrow answer is 1, a5 dot arrow answer is 0, az dot arrow answer is 0. So arrow dot arrow answer is 1, so answer is capital arrow. So that is why I have to write capital arrow is equals to a vector dot arrow vector. Okay, but now instead of this a vector, I have to put up my given vector. Okay, so my given vector is tan ax, this one is a very easy way, plus 4ay plus 2az dot arrow. Okay, so now this tan ax dot arrow. Okay, so this tan ax dot arrow plus 4ay dot arrow plus 2az dot arrow. Okay, so now it is ax dot arrow. Okay, so what is ax dot arrow? So you can see here ax dot arrow answer is cos phi. Okay, so ax dot arrow answer is cos phi, so it is tan cos phi plus ay dot arrow ay dot arrow answer is sin phi, so it is 4 sin phi, and az dot arrow answer is 0, so no need to write it. So it is tan cos phi plus 4 sin phi, it is arrow. Okay, so we have to first find out arrow. Okay, so we have to complete it for arrow. Now we do the calculation for a5. Similarly, we do the calculation for a5. Okay, so next find a5. Okay, so what I have to do for a5, that okay, whatever we have to do for the arrow, we do the same for a5. Okay, so here a5 is equals to a vector dot product with a5 unit vector. What is a vector? Tan ax plus 4ay plus 2az. So a vector is tan ax plus 4ay plus 2az dot product with a5. Okay, so now it is ax dot a5, ay dot a5 and az dot a5. Okay, so first ax dot a5. So ax dot a5 answer is minus sin phi. Okay, so this minus tan sin phi plus ay dot a5. So ay dot a5 answer is cos phi. So 4 cos phi, and az dot a5 answer is 0. Okay, so this a5 calculation. And next last calculation is for az. Find az. Okay, so az is equals to, we do the same way, a vector dot az unit vector. A vector is our given vector, which is tan ax plus 4ay plus 2az dot az. Okay, now ax dot az. Okay, as we know, ax dot az it is 0, ay dot az 0, az dot az is 1. Okay, so ax dot az 0, ay dot az 0, and az dot az is 1, so only 2. Okay, that I have already told. that value of Az here, it is 2. So this Az has the same value, which is 2, that we have proof. Okay, so now what is my vector in cylindrical coordinate system? My vector A is equals to, now what I have to do, I have to just put this value A rho, A5 and Az value in this vector. Okay, so answer is A vector is equals to, first A rho value 10 cos 5 plus 4 sin 5 A rho plus minus 10 sin 5 plus 4 cos 5 A5 plus 2 AZ plus 2 AZ. Okay, so now example is complete. So in this way I have to convert my vector, the given vector, into the cylindrical coordinate system, at which point the point P is given, which is x, y, z. Now suppose the same example may be asked in this way also. Convert this vector into cylindrical coordinate system at a point. Okay, now the point is changed. The point is P of, you can take any point. Okay, the point P of 2, minus 3, 4. That means the point is given in Cartesian coordinate system. Okay, now we have to convert this vector into cylindrical at this point. Okay, so now if you observe, the point is given in Cartesian coordinate system, so you have to convert this point into the first cylindrical coordinate system, and you have to find out rho 5 and z. Whatever the value of z that you have to find, you have to just put those value of 5 here. Okay, see here, 2 minus 3 and 4. So for 2 minus 3 and 4, the value of rho is under root 13. The value of phi is minus 56.3. Okay, so what I have to do in our example, in this example, I have to just put the value of phi is equals to minus 56.3. Okay, and do calculation and find out the vector A. Okay, suppose the given point is, point P is, the point is not 2 minus 3, 4. The given point is 2, 45 degree, 4. So we can say that the given point is in cylindrical coordinate system. It is itself in the cylindrical coordinate system. Okay, now the example is in this way. Convert a vector into cylindrical coordinate system at a point P of 245 degree, 4. So now what you have to do in this case, you have to directly put the value of phi, which is 45 degree, in our last equation. Okay, so the same example may be asked in a different ways. Okay, so what you have to do, first we have to assume the vector. Okay, and then we have to find out this variable A rho, A5 and AZ. Okay, so I have to convert this vector into the cylindrical coordinate system at a different of point. Okay, so now you can convert. Okay, now I have to pick up the last example, then we have finished this topic. Okay, so now I have to convert a vector into the spherical coordinate system, because if you see this table, which table is more difficult? Look like has a very critical. This table is a more critical compared to this one. Okay, so to convert a vector from Cartesian to the spherical is a difficult task compared to this one. Okay, so now example is convert a given vector. You can take any vector. Okay, suppose vector f. Vector f is equals to 10ax. I will just write 10ax. Okay, convert this vector into spherical coordinate system. Okay, convert this vector into spherical coordinate system at a point P of x, y and z. Okay, or R theta and phi. Okay, at a point R theta and phi. So convert this vector into the spherical coordinate system at a point P of R, theta and phi. Okay, so what I have to do? First we have to assume F in the spherical coordinate system, which is FR, AR, okay, F theta, A theta, and F phi into A phi. Now what we have to do? We have to find out value of FR, F theta and F phi. Then I have to put those value into my equation number 1. Okay, so first we have to find out for FR. We do the calculation for FR. So what is FR? So FR is equals to F vector dot AR unit vector. Okay, so what is F vector? F vector is given, which is tan AX dot this AR. Okay, so this AX dot AR. So AX dot AR is cos theta cos phi sin theta. Okay, so AX dot AR is cos phi sin theta. Again, AX, this one is AX dot AR is equals to cos phi sin theta. Okay, so we have to find out value of FR. Next, for F theta, so F theta is equals to F vector dot A theta unit vector. So F vector is given tan AX dot A theta. Okay, so AX dot A theta, AX dot A theta, which is cos phi cos theta. Okay, so this tan cos phi cos theta. And last, for F phi calculation, so F phi is equals to F dot A phi. Value of F is given tan AX dot A phi. So this AX dot A phi. So AX dot A phi answer is minus sin phi. Okay, so this minus tan sin phi. Okay, so it's very easy. So now to put all those value into my first equation. So FR value is tan cos theta cos phi sin theta AR plus value of F theta I have to put here. So this tan cos phi cos theta A theta, and lastly F phi, which is minus tan sin phi into A phi unit vector. Okay, so here the point is given, which is R, theta and phi. But if maybe the point is not R, theta and phi, the point P is, it may be something 2, minus 3 and 4. So what you have to do? The point is given in the in the Cartesian coordinate system. You have to convert into the into the spherical coordinate system that we have already converted. Okay, so this one is the value of R, value of theta and value of phi. So we have to put the corresponding value of theta and phi into my final equation, and you can find out the vector. Or the point is given in this way, point P is 4, 30 degree and 45 degree. That means directly value of theta and phi is given, so no need to convert it again, because directly value of theta and phi is given. You have to directly put here. Okay, so the example may be asked in so many ways. Okay, so here what we have to do? We have to just convert. Our topic is the conversion of point and vector from one coordinate to the another coordinate system. You have to just remember these things. Okay, you have to just remember this conversion, and from this conversion you can directly write this table. What we have to do? I have to just do the differentiation of the first column. What I have to do here? I have to just do the differentiation of the first column, but with respect to theta. Okay, so now we have finished this topic, which is conversion of vector from one coordinate to the another coordinate system. So in next lecture we will start what is dial operator. It is important. And what do you mean by the divergence, gradient and call operation. Thank you.